Hello friends, welcome to Electronic Circuit Hub. So today we are going to understand about how will you define a overvoltage category, that is OVC, for your product as per IEC 60335-1, as per IEC safety standard. Many of young engineers don't understand how to define a overvoltage category for your product what you are designing, and then later we will also understand what is the transient voltage, how will you define the impulse voltage for your design or for your product, and then later how will you calculate the clearance distance for your design. So many of young engineer don't understand all these things while they are designing the product. After watching this video, today you will have clear perception how will you define your design, or how will you select the overvoltage category, how will you choose the clearance distance. So friends, please join the channel membership by clicking on the join button. You can see here the different options, uh, and once you click on the premium membership, you can click on the join button here and you can support the betterment of this channel. Now let us understand what IEC 60335-1 says. How will you define over voltage category for your product, right? This is very important topic, guys. You need to understand thoroughly, right? How, let us say you have got some project and you want to design that product, and for that you have to define the clearance distance, you have to define the over voltage category. How will you do that? This is the topic today we are going to understand, right? So this is called in OVC. So let us understand by this picture. This is very beautiful picture which will give you a great insight here, right? Let us say this is your power grid, right? This is your power grid. You can see a big pole here. Okay, this is your power grid, and there is a supply coming from your power grid to your transformer. Okay, so this is the transformer, and then after transformer your supply going to your house or home here. Okay, so this supply coming from your power grid and that is going to your distribution panel comes under over voltage category 4. Okay, so from transformer to your distribution panel in home, let us say if you are designing this distribution panel, you should define your over voltage category for this distribution panel, which is 4. Okay, after the distribution panel, let us say it is going to your wall socket. This is your wall socket, right? So after distribution panel, this is going to your wall socket, and this comes under over voltage category 2. Okay, now you can see here a small charger, laptop charger is connected to your wall socket. Okay, so this, if you are designing your laptop socket, it comes under over voltage category 2. And now finally you are connecting your charger output to your laptop, and let us say you want to design your laptop, this comes under over voltage category 1. So that is how you will separate the over voltage category for your product. Okay, so starting from the power grid to the transformer, and then transformer to your distribution panel in home comes under over voltage category 4. Then from the distribution panel to wall socket, it comes under over voltage category 3. And then from wall socket to this charger, if you are designing this charger, you have to consider the over voltage category 2. And let us say you are designing a laptop, this comes under over voltage category 1. That is how you guys, now you hope you have understood how will you separate how will you understand the different over voltage categories for your product. So here I am giving one example. Now let us move. How will you define the impulse voltage for your design? Let us say you want to design this charger here, which is going to be connect at your wall socket. So this is, let us understand the specification for this charger. Okay, now let us come in this section where you need to define your rated impulse voltage. Okay, so mains transient voltage V peak, this column is your AC mains voltage, and it include up to and including, okay, AC mains voltage VRMS. And here you have now over voltage category starting from 1, 2, 3 and 4. Now as I said, you want to design your laptop charger which comes under over voltage category of 2. So this is your column, for over voltage category 2. And let us say for your application, your input AC input voltage for this charger can be or maybe 300 volt. Okay, so for 300 volt, what is your rated impulse here? Okay, so for 300 volt your rated impulse is 2500. This guys you need to understand very firm. Now you need to understand what is the clearance distance while designing your charger and its PCB. Okay, now let us go back in the next table. So this table defines the minimum clearance distance. Okay, this table defines the minimum clearance distance. Now you have, so since your impulse voltage is 2500, you should consider this 4000 category, and for this your minimum clearance distance is 3 mm. Okay, now you can see your minimum clearance distance for 4000 impulse voltage is 3 mm. Let us say in any case your impulse voltage is 1500, your clearance distance would be 0.5. So the rated impulse from 300 to 1500, your clearance distance is 0.5 mm. Then 4000 3 mm, 6000 5.5 mm, 8000 8.0 mm, and 10,000 that is 11 mm. So guys, I hope now you have understood how will you categorize your over voltage category for your product. Once you get to know what is your over voltage category, you can easily find the impulse voltage. And the third step is, once you know what is your impulse voltage for your design, you can easily find the clearance distance. So guys, that is how you can define your clearance distance for your PCB, your clearance distance for your design. If you have any further question on this topic, feel free to ask me in comment section. Thanks for watching this video.